So we understand that the death of stars is natural. But what's the creative role here? Can we say yes to the universe in the fact that our sun is going to die at some point? Well, here's where science comes in yet again. Atoms brings to mind periodic table of elements. 1870s started to be developed by Mendeleev, and a lot of other things plugged in since that time. What we understand now with Big Bang Cosmology, the scientific understanding is that in the beginning, after the energy cooled, all there was hydrogen and helium, the two simplest atoms, just great clouds of hydrogen and helium gas, was all that energy cooled into in the moment. When the first generations of stars lit up, they were hydrogen gas, gravitationally brought together to the point where the hydrogen gas in the core was having so much heat and pressure that it started to fuse, nuclear fusion. And at that point, the hydrogen began to fuse into helium. Helium was discovered as being a primary gas of our own sun, and then it was later discovered on Earth. So helium was named for Helios, one of the names for the sun. Big Bang, hydrogen and helium, when the first stars lit up, none of those first generation stars could have any planets around them, certainly no life, because none of these other chemical elements were born. How did they come into being? Well, first of all, in 1920, Arthur Eddington was the first to propose stellar nucleosynthesis, that the hydrogen was being squeezed in the sun and presumably other stars into helium. Now, he proposed it, but he hadn't worked out the equations. In 1939, Hans Bethe worked out the equations for how 4 nuclei of hydrogen are squeezed into 1 nuclei of helium, and then the mass that is lost goes out into energy, heat and light. Then in 1957, when I was in kindergarten, what I consider to be one of the most amazingly, mythically, religiously, spiritually amazing scientific discoveries ever, and yet most kids will never learn in public school because it's dangerous enough to have to teach biological evolution in a public school. What chemistry teacher is going to want to talk about evolution of chemical atoms if they don't have to? In 1957, Fowler, Burbridge, and Hoyle a group of scientists discovered that these atoms all were created in the fiery bellies of ancestor stars who lived and died and recycled their atoms back before our own sun was born. Right here, these forms in red giant stars, these in big blue stars that go supernova. Now, when I'm working with kids and younger people, I call this the new periodic table of elements. Hydrogen and helium in the beginning, carbon, nitrogen, and oxygen being formed when the hydrogen is used up in the core, and then the helium starts being squeezed into carbon. Our sun will do this when it dies in about 5 billion years. Stars slightly larger than our sun will also do nitrogen and oxygen. Let's take a deep breath for a moment. In, out. We've just breathed in a great deal of nitrogen gas from the atmosphere, oxygen, of course, and we breathed out carbon dioxide. Our very breath has us commune with ancestor red giant stars who created all those atoms. Let's take a look at all these elements down here: sodium, magnesium, aluminum, silicon, phosphorus, chlorine, sulfur, calcium. Think about the calcium in your bones. Some of us wish we had a bit more of it, right? Every single atom of calcium in your bones right now was generated in the fiery belly of a supernova star in the moment that it was dying. Every single atom of calcium. What this means, beyond the science, translated, what it means is we are recycled stardust. We are recycled stardust. Every single atom in us, except for the hydrogen in the H2O, carbohydrates in much of our bodies, those hydrogen atoms are 13.7 billion years. They've been here since the beginning. But all the other atoms in us, the carbon, the nitrogen, the phosphorus, the calcium, were birthed inside of ancestor stars who lived and died and recycled themselves, a gift, back to the cosmos before our sun was born. Such that when our sun was born, let's say that right here is 13.7 billion years ago. So here we have 13, 12, 11, 10, 9, 8, 7, 6, 5, 4.5, 5 billion years ago, right here. This is when our sun lit up. And there were generations. You remember, the gigantic stars live only 20, 40 million years. Generations upon generations of stars turning that hydrogen and that helium into more complex atoms, such that when our star started to aggregate with planets around it, those planets were not just gas giants. They could have calcium and aluminum and silicon and lead in them and iron, and thus become possible for life to happen. Without the death of stars, there would be no planets and no life. If we value life on planets, then the death of stars is something we're grateful for. Even though it means our own sun will die, right? Even then. Death is natural and generative even when it comes to the heavens. What a reversal of our understanding. On Easter, many religious Christian churches will celebrate that you had a death of a God-man here on earth that then allowed the rest of us to perhaps gain immortality in heaven. I see a reversal of that. We have the death in the heavens, mortality in the heavens, then even make it possible for there to be any life on earth. How greatly our cosmology has shifted, and how little our religious traditions have taken advantage of bringing this in ways that can enrich their core concepts about how to relate to the universe as a whole, or the divine, and how to be with one another. Carl Sagan, 1980. How many of you saw Cosmos when it first aired in 1980? I did as well. Remember, near the end of Cosmos, the great Carl Sagan says this: "We are the local embodiment of a cosmos grown to self-awareness. We have begun to contemplate our origin. We are star-stuffed, pondering the stars." We are made of stardust, every single